We do have our other presenter who's also virtual online at the moment, and that is engineer Simon Pitchers, who started his career in 1973 as a tea or chain boy on a massive dock construction project. He then went on to open Craddys design firm with over 70 employees, which he is the managing director of. He's a fantastic person. He has many accolades. He's very entertaining, which you would be able to tell although he's online. So Simon, without further ado, I'll hand over to you. Thank you, Mina. Thank you so much.
Thank you very much.
Right, well, what an honour it is to be here, and I just want to check, first of all, can you hear me okay, Shalini? Because I can't hear anything.
Loud and clear, Simon, loud and clear.
Have you got a decent...
And I see the new headset as well.
Yeah, I've got a headset specially for this occasion. I've never used one before.
Excellent,
Great.
excellent.
So we're cooking on gas.
We are.
That's brilliant. Okay, well, what an honour it is to be speaking to everybody today. Thank you so much for inviting me. And just like Mina said, I wish I could be there in person as well. But I'm getting on now, and I probably wouldn't do so well on a flight like that. And it was very nice what Shalini said, but the truth of it is that actually I'm pretty well retired now. So I started off my life in the building industry as a lackey, making tea for people on site. Luckily, my mum forced me to go to university, and then I joined this firm called Craddys. And this, for those of you who are young observing this, you won't recognise this, but it's an early form of CAD system, which we used to use at Craddys to produce drawings. And Craddys grew, and I've actually retired from Craddys now. I've been retired from them for a while, but I've been working a lot for the Institution of Structural Engineers, particularly concerned with the aftermath of the Grenfell tragedy. And I've also, I've got a share in a company that builds supermarkets. And occasionally, when they haven't got anybody else to call on, the BBC will ring me up on Radio 2, Jeremy Vine, and ask me questions, usually about subjects about which I know nothing, but I'm able to bluff my way through most of the time. So now I'm sort of almost retired. I've got one very, very demanding client, and she wants me to build this extension on our house. So in fact, my career has gone a full circle, and now I'm making tea for the blokes on site. And so I started off the way I finished, or I finished up the way I started, let's put it that way. Anyway, I'm probably the least intellectual person you're going to hear in this entire conference. So I thought to give myself a bit of credibility, I'm going to give you an equation. There it is, U equals 1 over N. I'll leave you to ponder that. We'll return to it later. Simon, and now I'm going to tell you what I'm going to tell you. Sorry, did you say something, Shalini?
Yes. We're not able to see your presentation.
Oh, my goodness. Right. Let's just try again. But you heard all that.
We did, loud and clear, loads of laughter.
But you saw nothing.
We saw nothing. We saw you. Very expressive facial features, yes.
Oh, even worse. I mean, I've got those bloody slides that you're supposed to see. So I'm sharing screen 2, and let's just try doing that again. Hang on a sec. So let's go into presenter mode. You're still not seeing me, are you?
We can see you, but not the slides.
Not the presentation. Okay, so
we could do a flip chart.
Right, I'm going to unshare my screen, and then I'll reshare it. So, share. Okay, are you getting a blue screen
We're
now?
getting a blue screen, yes.
Oh, thank heavens for that. Well, let's go back to the beginning. The trouble is you'll have missed all the jokes now. There we go. Right, so...
Yes, this presentation.
There we go.
The coffee, yes.
Right, so we're there now, aren't we? We're back at the beginning. So can you, is everything there now,
yes.
Shalini?
Yes.
Right, great. So there we are. Let's just quickly whiz through these. Started off as a T-boy, went to uni. That's the CAD system that we used at Craddys. Then the Institution of Structural Engineers. That's the supermarket firm. Radio 2, that's my existing client. very, very demanding. That's the project I'm doing, and so I'm back making tea. So we are, now that's the equation for you. Okay, that's the equation you've got to try and solve later. That's to make up for my lack of intellectual capabilities. So anyway, this presentation, what's wrong with the industry? That's the first thing we're going to talk about. Then I'm going to talk about the new guide, which I was lucky enough to be made the author of, and how to use it. And it might be useful to people who are watching this presentation. And then getting paid for using it as well, because we are a business. We've got to make sure we keep getting paid, otherwise we'll go out of business. And then a quick recap at the end. And the impact of the initiative as well. And the first thing I want to do is to ask you a question. Have you experienced your designs not being built right? Well, I can tell you I have. And I can tell you that probably in 50 years, I don't reckon a single one of my designs was ever built perfectly. And to be absolutely honest, varying degrees of uselessness in terms of construction. Some close to being correct, but many of them not correct, and increasingly frequently not as good as they should have been as I got to the end of my career. And here's an example of one that went really badly wrong. So this is the Edinburgh Schools problem, 2017, a building that had been up for less than 10 years. The wind blew in the wrong direction, 9 tons of brickwork fell down onto an area that was used by school kids. It could have been an absolute disaster, absolute disaster. And what was the cause of it? Well, you see the top left-hand photo there, that's the end of a wall tie, and you see to the right of that, that's the wall that it should have been built into. So it's not actually built into the wall at all. So you see the photo underneath, there's another wall tie, which has got about 10 millimetres of embedment. And here's a view down the cavity, a very wide cavity, and you can see that the problem was absolutely widespread. There were virtually no wall ties bonding the two leaves together. And it went further than that, because at the top of the wall, there had been designed, the designer had quite properly designed, a proper restraint system which would be bolted to the steelwork, would extend down the cavity, and then you had a stainless steel cutlery set, effectively, which would hold the two leaves to the vertical pieces that extended down the cavity. And they found those components resting on the top of the wall when they did their investigation. Now, what's really astonishing is, this is 2017, every tick sheet you can imagine had been ticked by every QA specialist that ever lived. Okay, it was absolutely ticked to pieces, the tick sheets, and it didn't make the slightest jot of difference. And that's one of the learning points really from all this, is you just can't rely on tick sheets. And then we move on to really the terrible Grenfell disaster. Now that the most recent report doesn't say that the principal cause was bad construction, but there was poor construction involved as well. The main cause of the problem was the use of the incorrect material on the outside skin, and also the incorrect insulation as well, which was inflammable. But you see, the regulator in the UK has got a lot to do. They've got to manage and update their system. They've got to check designs comply with the regulations, so they've got to check all the designs. They've got to do auditing of their inspectors as well. And then they've got to carry out stage inspections of construction. And people think incorrectly that that's enough, but it isn't. I mean, I've worked on site loads. I'm sure lots of people here have as well. And what you do when you know the building control person's coming round, you cover everything up and you point them in a different direction and make sure they don't see what's wrong. And I'm afraid that's what it's like in the construction industry. So what you really need is comprehensive scrutiny of construction, and nobody does that, and it's getting worse. And that's the big problem. Now, you look at this. This is SCOS, or CROSS, I should say, sorry. This is a report that they produced on why things fail or go wrong during construction phase. And if you look at that as a whole, it would appear that in somewhere between about 80 and 96% of the time, if there had been scrutiny on site, then those things wouldn't have gone wrong. And so I think scrutiny is a really important thing that's completely overlooked. And I think it's something that we all need to make an effort to get it right. I mean, the thing is, people say it's competence, but I've got a license that proves I'm competent to drive. But I'll tell you what, when it comes to observing the rules, I'm much more likely to do so if I'm under scrutiny. Okay, so the ideal scenario would be to have everything in every building scrutinised while it was built. But you then come up against this problem called proportionality. Okay, there's only so many people out there who are able to do the scrutiny. And so the problem that you've got is there's not enough resource to scrutinise the whole of all buildings being constructed. So we've got to find a better way. And that's where this guide comes in. Now get ready with your camera phones, because there's a QR code that you can photograph in a minute, and you'll get this document for free then. And it's like the notes to this lecture, really. So the guide is called this. It's published jointly by the Chartered Institute of Building and the RIBA. I'm the author, but there was a huge amount of input from people who have been involved in problems where lack of scrutiny has been present, particularly the Edinburgh schools disaster. That we had the person who was actually the person who did the inquiry sat on the panel. And it's called A Guide to Managing Safety-Critical Elements in Building Construction. It's not a very catchy title, I appreciate that, but it does actually bring about some quite useful stuff for you that I think you will actually benefit from, no matter which country you're operating in or how you actually operate. So the ideal scenario, I'm going to leave this, but don't worry, we'll get it again at the end, okay? The ideal scenario is that we actually look at every single thing that's being built, but we can't do that. So there's just too much to look at. So what the guide does is it shows you how you can identify safety critical elements, and then it explains how to deal with them so that we're only focusing on the elements of key importance, reducing the inspections and the amount of evidence needed. Now let's come back to this, U equals 1 over N. And I have to say, really, because Mina produced the most fantastic presentation just now, and I don't want this to be derogatory to anybody else, but I've got a theory, and my theory is this, and that is the usefulness of a document is inversely proportional to the number of words it contains, okay? Now I'm talking about documents that are meant to have an instant impact, really, I suppose, that kind of thing. So usefulness is inversely proportional to the number of words that it contains. Now you'll be pleased to know that you can read the whole of my document in 12 minutes. That is from the end of the contents page to the beginning of the appendices, 12-minute read. Okay, so there's no reason why you can't download it and read it at tea break time or when you're going home tonight or something like that. Okay, and I reckon, and I know this is an outrageous claim to make, but I think this is a silver bullet. I think it's something that if it was implemented on all projects, we would just transform the industry. Carbon saving as well. That would be something else which I'll come to at the end, which would come out of this. So I really do think this could solve so many problems. Now, if it had actually been implemented, I don't think, for example, Edinburgh schools would have ever gone wrong, and certainly Grenfell, it would have stood a much better chance of not have happened. So this is the key principles that are sort of embedded in the guide. And I'm just giving you a kind of flavour of this, and then we'll dig into it in a bit more depth. So you have key principles in the guide, they're set out. And then what you have to do is you have to think about an element, and you have to decide whether or not it's safety critical. And I'll show you how you do that, and that's set out again in the guide. If it is a safety critical element, then you have to apply the key principles to that safety critical element. And what you have to do is you have to write down what evidence is going to have to be collected to demonstrate that the element has been installed correctly. And the guide explains that as well. Then you apply what's in the guide, and next you have to decide who's going to do the site inspections. And I'll cover that shortly as well. So after construction starts, they do their inspections and they gather all of the evidence required, which can take many different forms. And again, I'll cover that shortly. And then when the evidence is all collected, it's all provided to the people who are running the project. We call them the principal designer and the principal contractor. It might be just incorporated in the as-built information, but it's sort of woven into what we call the golden thread in the UK, which is supposed to be a repository of information, which is the sort of Bible, if you like, about the building. So that's the whole thing in a nutshell. So let's go into the key principles. What are they? And they're going to affect all corners of our industry. So let's start off, first of all, with the client. So the client now, if they follow the key principles of the guide, they need to give their teams a mandate for checking and inspection. Okay, so often clients think this is already built in to a project, but it seldom is. Okay, it's normally whistled away by members of the client's team, thinking it's unnecessary, but it's vital. And also, the client needs to stay more closely involved with their project. They don't want to just hand it over to people. They need to keep returning to it and checking that what they have set out to do is being done. So in the employer's requirements, they need to set out not only what's expected of the builder, but also how inspections are going to be made during the design, and then how inspections and evidence collection will need to be made during the project. Then, throughout all the phases of the project, the client needs to check and get evidence to show that the client's instructions are being followed. So they don't just walk away. They first of all give you a mandate to do all the checking and inspection, and then they check that all that checking is being done. Okay, and this is the whole thing here: evidence, checking, making sure things are being done. That's what it's all about. So that's the client. Now let's move on to designers. I'm a designer, so this is the most important bit for me. Designers need to be a bit more inquisitive. So how can we do that? So as well as completing their designs, rather than just walking away or doing periodic monthly site visits, which is what we normally finish up with in the UK, and no proper inspection of what's happening, as the design progresses, they need to decide which elements are of key importance. Those are the safety critical elements, and which should be independently inspected, and what evidence should be collected, to prove compliance. And then during the design, designers should ideally carry out these independent inspections on their own designs. That's the panacea. That's really the utopia image that I've got in my mind, where you actually go out and you inspect your own designs on site every time one involves a critical element, safety critical element. And if they can't do that, at least ensure that somebody independent, checks the designs. And that, again, has to go on through the project. So inspecting and reporting on those inspections, then inspecting and reporting on those inspections. So that's what designers have to do. And that is called an inspection plan. So you have an inspection plan before you start. You might already do this, I don't know. But we certainly don't do it properly in the UK yet, but we're gradually dragging ourselves in the right direction. Now, what about quantity surveyors? Well, quantity surveyors need to broaden their horizons. They don't want to just be all about value engineering and cutting costs and cutting capital. I mean, it just drives me mad. I was out the other day in Weston-super-Mare, wandering around a block of flats, and I can remember thinking, I told them to hot dip galvanise those balustrades. And they didn't. The quantity surveyor said, no, too expensive, Simon. We want to save ourselves £1,000 and we're going to paint them. And now they've got a sort of 7-storey building and it's going rusty because it's by the seaside. And it's going to cost a fortune. Such false economy. So instead of driving costs down, quantity surveyors, they need to keep an eye on costs, but they need to look further than capital costs. And they've got to start believing in the value of proper inspection and collection of evidence to prove compliance. They need to appreciate how this can save vast sums of money. I mean, you look at the money that's being expended in London at the moment on things that have gone wrong. Whole buildings are being demolished and rebuilt as a result of this. Okay, you think of the carbon footprint of that. It's mad. All we've got to do is just make sure that we're doing it right the first time. And what they need to do is make sure the inspections are being done, and they need to check up on the inspections and check people are collecting the right evidence as well. So it's maintaining this involvement and valuing checking. That's the thing. What about builders? Well, builders really need to make their instructions much, much clearer to the people who are operating for them. So quite often in the UK, you'll have a main contractor and there'll be a lot of subcontractors who are functioning under their control. And quite often, I find that the subcontractors really don't get the full message as to what they should be doing. So that message needs to be clearer. But also builders need to then go out and monitor and make sure things are done correctly. And again, that's something that we certainly are lacking in the UK. So they really, until competency improves across our industry, and it will eventually, but you just can't assume all operatives are absolutely competent or know what they're doing. So you've got to really clearly explain tasks. Perhaps give them training before they do the task, toolbox talks, that kind of thing, toolbox talks, just to make sure it's absolutely crystal clear. I mean, embedding a wall tie, you really would have thought that was an absolute basic thing, wouldn't you? But you can't assume that at all. That's what that whole Scottish Schools inquiry tells us. And we must no longer assume that tick sheets prove compliance. They prove nothing. They just prove you can tick a sheet. That's it. Builders need to tell operatives and clients what evidence needs to be collected during construction to show each completed evidence. If a person who's putting in a wall tie knows that they've got to have a photo of that wall tie properly built in, they'd probably build it incorrectly, won't they? So if you tell them what evidence is going to be required in advance, they're more likely to do the job correctly. And then as work progresses, builders need to really keep an eye on not just workmanship, but materials as well. Make sure that the materials that come on site are the correct materials. Make sure the wall ties are long enough. I mean, those wall ties weren't long enough. That's why it all went horribly wrong. And also make sure they're getting proper evidence as the work progresses. So that's how we've all got to change. That's how all the disciplines have to change. What about the process? Well, the process really needs clarifying, needs simplifying, needs refining, and it needs streamlining. Just got to get smarter with this. So this is some examples. Really, you shouldn't be allowed to start work until the design is complete. Only then should you then be allowed to start work. Now, I know that sounds, you may think this is basic stuff, but honestly, it happens all the time where you'll have builders starting work on site and they've not got proper information to build from. And then we complain that our work isn't built correctly, and that's the reason why. It's not their fault. You know, it's that if you don't have proper information and you've got a program to meet, you just crack on, don't you? Another thing, changes. Okay, so if the design is changed, you've got to stop, not do anything, because you need to consult the people who are stakeholders in the design, building control, the client, other members of the professional team. Now, when they say, yeah, we're happy, that's when the change can be implemented. Now, change, as everybody probably knows, is the mother of disaster. So you've got to control change. Change inevitably happens. We've just got to keep a lead on it and just make sure that everybody's happy before it's implemented. And having to go through this process, it'll slow things down, but it'll make us a lot better at getting it right first time. Now, when people arrive on site, before people are deployed, you've got to check their credentials. So principal contractor needs to get evidence from each of the people who are operating on their site to show that they're competent to do the tasks that they're going to do before they're let loose on the site. And the other thing they need to do, as I mentioned earlier, they need to make sure that these people know what evidence is going to be required of them before they actually start working as well. So in a nutshell, everybody in the team needs to take a bit more responsibility. That's really what this whole guide is all about. Now let's get into the nitty gritty now, shall we? So identifying safety critical elements. How do you do it? Well, it's straightforward. A safety critical element is any element which, if it was either installed incorrectly or if it was omitted, it could result in a death or a serious injury. Okay, so it's quite a simple definition. And what we've done in the guide, we've grouped and we've given examples of what safety critical elements are. So the first sort of grouping is anything that stops flame, heat, smoke, elements that could accelerate the spread of fire and smoke, controlling them in the interior or up around the exterior of the building. Those sorts of things, anything stopping that is a safety critical element. The next category is anything that might impede escape in the event of fire. So, for example, that would be a safety critical element, that ladder that just fell down. And here's some more examples. So, a hole through that wall there, that would be a safety critical element because it could allow a fire to spread into through a fire compartment, or obviously a hole through that wall, or that fire door. That could be a real problem as well. So there's a lot of fire safety related items that could be a problem. Now, the next category of safety critical elements are things that stop people or objects falling off or out of buildings. So those fixings on that balcony, they would be safety critical. Those fixings holding that suspended ceiling in place, those would be safety critical. Those wall support units that are attached to the outer lead, those would be safety critical as well. And those mount systems that are holding onto those PV panels. I had a PV panel blew off the roof of a supermarket and it went through the back window of a Range Rover and there was a child on the back. Luckily, nobody was hurt. But it just shows how dangerous these things can be. One loose screw and you're really in trouble. Wall ties. Sorry to keep harping on about wall ties, but they're just such an easy target. And the things that restrain stone as well. So those are things that stop things or people falling off buildings. Or let's move on to the next category. This is collapse. So things that prevent collapse. So things like precast units and their connections, steel beams and their connections, big retaining walls, making sure that those are built correctly. They are safety critical elements. If they go, you could have a real disaster on your hands. Post-tension slabs, that's another one. Masonry reinforcement in walls, if you forget to put that in, the wind blows in the wrong direction, you could be in big trouble. And also there's this one that deserves a mention. That's the Hyatt Regency Hotel in Kansas City, which collapsed in 1981, and that was suspended on tie rods. And it wasn't the tie rods themselves, it was a change that actually caused that particular disaster. But anything that's on a suspension system like that, you can see there are safety critical elements involved. And that sadly is that Berkeley, California 2015 bay window collapse. And you can see the bay window above has fallen onto the bay window below. And you see those sort of stumps sticking out of the wall. Those were decayed timber joists, which were cantilevering from the face of the building. And those obviously were safety critical elements. Another category is things that provide protection from or could detrimentally interface with hidden hazards. So, for example, if you've got a tunnel and you're driving piles near the tunnel, a safety critical element would be that pile because it could possibly go through the tunnel. So that would require extra special scrutiny. And another example is gas-proof membranes. So a gas-proof membrane, somebody described it to me as flat roofing on the ground. And you've got to be so careful that there isn't a gap in it. Otherwise, the whole system could fail. So again, gas-proof membranes, those are safety critical elements. Now, it's not just the element itself that makes a thing safety critical, it's its location as well. So if we look at these three slabs, that one's a safety critical element, and so is that one. Okay, but that one there is not, because it's a ground-bearing slab. So if it failed, it wouldn't hurt anybody. So it's not a safety critical element. And if you look at cladding panels, okay, the top one, that's a safety critical element, because if that fell off, so the fixing to that cladding panel would be a safety critical element. But the bottom one is not going to hurt anybody if that one falls off. So that one isn't a safety critical element. So there you go. So I think you've got an idea, a flavour now of how you would identify a safety critical element. And the guide that you will get, you get it for free by clicking on that QR code that I sent you, that explains it in more detail. So let's move on now. Let's look at scrutineers. So who can be scrutineers? Scrutineers who are going to look at that safety critical element. Now, don't forget, safety critical elements require independent inspection. But what do we mean by independent? How independent is independent? Okay, so what you wouldn't want is for a scrutineer to be directly involved in the construction of the building. Otherwise, it's like they're marking their own homework. Okay, so you wouldn't want a scrutineer to be from the main contractor or from the subcontractor's construction arm. However, a scrutineer could be a third-party certifier. Now, quite often with gas-proof membranes, you have third-party certifiers who come to site, they review on behalf of the manufacturer that the thing's been installed, and then they give you a certificate at the end. That's a good solution. Clerks of Works, but I don't know what it's like where you're from, but in the UK, clerks of works are incredibly rare. The numbers of clerks of works have virtually quartered, I would say, in the last 10 years. Okay, it's very, very difficult to get clerks of works. So who is there left who can do this scrutiny? Well, designers. That's where we need to step in. Designers could do this. And in fact, we are the best people. Designers are the best people to scrutinize their own designs. You understand the risks better than anybody. So who better than designers? But you'd need to get paid for it. You couldn't do it for nothing. And you wouldn't want massive liability in so doing as well. But we thought through that as well. And also manufacturers. Manufacturers don't want their products installed wrong. So they are good people to come out and scrutinize. So that's where you can get your scrutineers from. Okay, evidence. Let's just talk about evidence. How do you specify the collection and retention of evidence? So first of all, how do you actually specify an element? Now this is really, really critical if you're doing scrutiny. First of all, you've got to be absolutely clear about what scrutiny you're doing. You can't just give some kind of generalized comment saying, I'm going to visit the site so many times a month and look at the safety critical element. It just won't work, okay? What you have to do is you have to be hyper analytical on where the elements are. So you might issue a plan. Let's go back to wall ties. And you might say, I'm going to look at the wall ties that are involved in the construction of that plan. But that's not good enough, okay? What you need to do is you need to mark up which bits of the plan had the wall ties that you thought were safety critical and needed scrutiny. But that's not enough, okay? Because you need to show them on elevation as well, because it might mean that you're doing all of the wall ties from ground floor up to roof, or maybe just from first floor. Who knows? So you need to shade that in on a plan or find some other way of being very specific. Okay, so you're sort of saying where the location of the element is now. You're being very specific in that regard, but you also need to say what you're checking against. So you need the specification and you need to highlight which bits of the specification you're going to check. Now, if you do those things, the scrutiny that you're going to provide to the project is absolutely nailed down. Nobody can say, well, you were on site and you should have seen that. No, I went on site and I was just looking at these things. That was my specific job, and that's what I've done, and I've done it with reasonable skill and care. So I didn't look at anything else. That is all I have been contracted to look at. Okay? That then gets away from the age-old problem of why designers are quite often, quite rightly, concerned about stepping on site, because they may get landed with all sorts of stuff. And it's not just your inspections that you need to rely on when you're thinking about whether something's good enough or not. You may also depend upon other scrutineers providing you with their evidence, and you can take that into consideration when you're thinking about what you see. It might be people on the builders may say, here we are, here's a load of reports we've done showing these wall ties. And you may say, well, that's very good. You've got all the photographs. Yeah, I feel a lot more comfortable, but I'll go out and have a look at a few now myself. You see what I mean? So it's other people's input as well is what's going to help you with your scrutiny. Now, what sort of things will you be bringing back as evidence? Well, things like packaging labels. Okay, photocopy them, put them in the evidence pack. invoices, manufacturers' fixing instructions, okay, certification for elements that you're looking at. Photographs, particularly vital if things are going to be covered in. You need to really have properly organized photos so that you can go back and see what things look like before they were covered up. Video footage. Some builders really like CCTV camera footage, we found when we've been using it on site in the UK, surprisingly actually. Body cams, you can get geolocated body cams where you can actually tell where the wearer was when the video was taken, which is quite good. And obviously things that give evidence of qualifications. Those are the sorts of things, and there's a comprehensive list in the guide, but those are the sorts of things that you would use for evidence. But most important of all are reports. And the sorts of reports that I would expect to see in evidence are things like an initial briefing, where you might, if you're doing a piece of scrutiny on a certain element, you might go out to site, you might brief the team and say, look, be very careful about this particular thing and that particular thing, easy to go wrong. You know, initial briefings are really worth their weight in gold. Material inspections, when things come to site, they should be looked at and checked. Test results, you might have some pile test results and the interpretations that go with them. You may be using those to go with your own evidence that you're going to put forward as to whether the critical element is okay or not. Contractors' inspections, they should be providing you with those. Contractors' sign-offs where they say, yeah, we looked at the whole of this, we've looked at all the evidence, we believe this is right. It's their responsibility to get it right, not yours. You're just looking at a certain snapshot, if you like, of that critical element, nothing more. And independent inspections, like the people who are putting in the gas-proof membranes, other designers, manufacturers, clerks of works inspections, all of those sorts of things. Those are all evidence. Now, this is the bit, inspection reporting. A lot of people are scared of reporting on site visits because they see it as a way that their liability can be extended beyond where it should be. But there's no need to be scared. Okay, it's that wobbly hand moment where you actually have to put pen to paper, but you're not actually signing to say that the critical element has been installed correctly. You're not signing to say that. What you're signing to say is you're signing to say, this is the critical element. This is what I've just gone and done. I've gone out and looked at it on these dates, and this is what I saw. Okay? And as long as you do that, you may draw a conclusion from that. The conclusion won't be that everything's all been constructed completely properly. Your conclusion may be that from the evidence that I saw, I've seen nothing to suggest that it hasn't been built correctly. That may be your conclusion, and that would be perfectly reasonable on the basis of what you've done. But you can really contain your liability if you do inspections like that and you report like that. Okay? Reasonable skill and care, that's the measure. The contractor remains responsible for compliance with the design, not you. So, also, if you're checking a load of elements that are very, very similar, like wall ties, how do you do that? You can't look at every single one. Well, what you do is you decide on a sampling percentage, maybe 10%, okay? And you go out and you start off by looking at that percentage. Now, as you work, you may find that actually they've all been installed brilliantly, all the ones that you've seen, in which case you may say, okay, well, I'll reduce the percentage of my inspections. Now, I'll only look at 5% or 3% or 2%. On the other hand, you may find that the 10% that you looked at were all installed appallingly badly, in which case you'd want to increase the frequency of your inspections, and you probably want more money for doing your inspections as well. So those are the two scenarios. But don't forget, all you are looking at is what you've signed up to look at, which is that which is shown in the green in this graphic here. Now, what sort of form could a declaration, a sign-off declaration from you take? And if you've got your camera, you might want to take a photo of that because that's not actually in the guide. And this hasn't come from a lawyer. It's something that's just been really dreamed up. So you'd need to check it with your insurers. I've had a word with our insurers about it, and they said, yeah, that's the right kind of lines. That's the sort of thing that would cut the mustard. But you need to check it with your insurers as well. But you can see the idea there is you do all your definitions at the top, and then you just say what you've done. And then on the basis of that, we've got no reason to consider that the part of the project reviewed has been constructed anything other than generally complying with the design. And that's an insurable risk. And in fact, insurers love this because it means no longer have they got this kind of woolliness of when you go on site and you could have seen anything and it might have been wrong. You're focused on this one thing. Okay, so insurers like this kind of stuff. Well, you're probably thinking, this is going to cost a fortune. It's unworkable, Simon. You are in a dream world. It's never going to happen. But I would say this to you. Which is more complex? Okay, let's say that's a £15 million civils project. Let's say that, not the big one, but the one to the left of it, the little one, is a £15 million building project. So which is the most complicated of the two? Obviously, the building project. However, a typical £15 million civil engineering project will have a resident engineer. This is in the UK. We'll have a resident engineer. He will have a team of subordinate engineers working with him, and they'll have an admin team working with them. Okay, and that is the sort of scrutiny you will get for a £15 million civil engineering project in the UK. Moving on to the building project, sort of scrutiny you will get on a building project, if you're lucky, is possibly one clerk of works, and you might not even get that. Okay, and what all we're trying to do is to get parity here. We're just trying to get the same level. Really, it should be more scrutiny than you'd get on a civil engineering project onto a building project. So the problem at the moment is that we just don't pay enough for scrutiny. We don't value it. We don't see how much money it can save us. Right. So how are you going to get paid for doing this scrutiny? Now, in the UK, we've got legislation. And if you can get legislation, or if you've got legislation and you can use the legislation to your advantage, then that is the way to do it. In the UK, we've got legislation that relates to higher risk buildings. I won't go into what they are, but there are completed certificate applications. These are required before occupation. So you can't actually move into the building until you've got one of these. Okay, it's a statement signed by the client confirming that to the best of the client's knowledge, the higher risk building as built complies with all applicable requirements. Okay, now the only way that any client is going to do that is they'll need a declaration signed by all of the leading people who are involved in the project. And indeed, that's the law as well. You have to have that. Okay, what about non-HRBs? Well, it's a bit vaguer, UK law. Clients must provide resources to ensure compliance with building regulations. Okay, so it's sort of there. And we're finding now in practice, some building control authorities are requesting signed declarations and evidence of compliance from principal designers and principal contractors, and good for them for doing it. And that's becoming increasingly the norm for non-high risk buildings. So because the top people involved in the building projects are being asked for evidence, they're having to go back to back with their subordinate designers and their subordinate contractors and the subcontractors, etc., to get back-to-back documentation to underpin their declarations. And a solution to that is simply to follow the guide that you've got the QR code for. So I can explain that probably more eloquently in this slide. So if you've got the client now needs to provide a declaration. The only way the client will provide a declaration is if the two main people building their project also provide a declaration. Now, the only way that they're going to provide a declaration is if the people that are working for them also provide declarations. So let's just look at one of them, a designer, say, and the only way they're going to be able to provide that declaration is if they're working really, it's not the only way, but a way that they're going to be able to provide that declaration is if they've got scrutineers going out on site, checking that their safety critical elements are being built correctly and producing all that evidence. And that at the bottom, all those little coloured boxes, those are all the bits of evidence that you need now to show that something has been built correctly. There you go. I'll just let you, that's not in the guide, that graphic there. So you might want a photo of it. I don't know. Probably now you explain it, now it's been explained, you don't need it. But that's the evidence, the stuff with the green line around it. And that's what's kept in the building file forevermore, so that people know what happened. So how can you influence things? Well, you want to make the project manager aware of this guide. That's one thing I would do. Give them the QR code. They can download it and read it in 12 minutes. And also the client needs to be aware that this is now best practice. And without implementing it, there's a heightened risk of latent defects that might not emerge until maybe 10 years later after construction. And ask them if they'd like a fee proposal from you for carrying out the inspections in the guide. And if they say no, then gently confirm to them that the design team obviously can't be held responsible for the consequences of ignoring best practice. Okay, and if they come up, it'll be somebody else's responsibility. That's the way to tackle it, I would suggest. Let's have a little recap because we're getting to the end now. So you've got your key principles. Make sure you're familiar with them. Decide which elements are safety critical elements. Apply the key principles to the safety critical element. Write it all down in an inspection plan. Choose your scrutineers. They don't have to be brains of Britain. You know, they don't have to be senior partners. A suitable person for checking a concrete pour might be the person who detailed it. Okay, they'd probably be the best person, to be honest. And decide what evidence is going to be collected and collect the evidence. And then once you've got the evidence, it all gets wound into the golden thread. What's the impact of this? Well, it's going to be quite quick because unlike big time legislation, which works top down, this works bottom up because you're getting straight to people who are on the tools doing the work. And those are the people who really make a difference to whether a building is built correctly. So this is a fast track way of really getting things to start working properly. What's going to be the wider consequences of this? Well, the skills of the workforce, they'll start to rapidly improve. You don't want to knock down a wall too many times and put new wall ties in for free, do you? You want to do it right first time. People soon learn if they're under that kind of scrutiny. And so the quality and the safety of our buildings, that will improve. It will improve quite quickly. The other thing that's going to happen is, at the moment, there's a disconnect between site and design. You know, if you're a young designer and you want to go out on site in the UK, quite often you're not allowed to. You know, there's not the provision for that. And as a consequence, builders quite often complain that you get these unfeasible, impossible designs that they just can't build. Okay, and it results in undesirable remedial work and unnecessary carbon usage. So what's going to happen is the design quality and buildability will improve, and also design safety will improve as well. So the other thing that will happen is,
Simon,
if you start
sorry, if I may just interrupt you. We're just running quite far behind schedule, so if it's possible for you to wrap up in about 2 minutes, so that we just have
I've
time
only
for
got
a few
2 minutes
questions.
left, Shalini.
Yeah,
Thanks for mentioning that. Yeah, so we've got a huge amount of waste in our construction industry, and of course, as the waste reduces because people are doing it right, efficiency will improve, and your carbon footprint will reduce as well. And also, changes will become properly recorded. I don't know if you've ever found as-built drawings. I don't call them as-built drawings. They're absolutely nothing like what was built drawings. That's all the as-built drawings I've ever seen. They've never, ever reflected. Well, our as-built drawings will actually be as-built. They are, Shalini. It's not individuals are problematic. It's the system. And what we need is a bit of courage now. We need to get together, work collaboratively, get the wheels grinding away, and see if we can get this thing to fly. So, what do you need to do next? Get the guide, and then if you've got a project on which it's adopted, please let Patrick Hayes at iStruct HQ or me know. And we'd love feedback for the next edition. Thanks very much, everybody. What a fantastic privilege it's been to speak to you. Thank you very much.
Thank you, Simon. That was excellent. Now I will quickly just ask if there are any questions for Simon. Yes, there's one question there. Yes, thank you.
Hello, Simon. Hi. Good morning or good afternoon.
Are you able to hear Simon?
Yeah, I can hear loud and clear. Thanks.
Great.
Hi, Simon. Thanks for finally getting to the really important person who's been lost over the past, 40 years. The clerk of works on site. He was the most responsible person to pick up all of these in construction mistakes, especially in real time. A lot of the suggestions you've made are to do with post mistakes being made. If you have a lot of inspections to do and a lot of paperwork to get out and to present to clients or designers, it's usually after the fact. The great thing about the old-fashioned clerk of works who really knew his stuff was that he was able to stop the work straight away, make the phone call, and get somebody down from the designer's office or the engineer or the M&E guy or whoever and correct the situation. And it's the loss of that particular person in the design and the construction stage which has been responsible for quite a few mistakes and disasters as well. Thank you.
Yeah, that's a brilliant point. But the unfortunate truth is there just aren't clerks of works about these days. And what we've got to do is we've got to step into those very big shoes ourselves as designers. And the whole idea here is this. If you're on site and you're doing an inspection of something and you say to the person who's doing it wrong, look, you're doing it wrong. And he says, look, mate, I've been doing it this way for the last 30 years and I'm going to carry on doing it. And then you say, well, look, I've got to do a report on this inspection. And if my report says you're doing it wrong, nobody be allowed to occupy this building. That will have an impact. So we can step into those shoes and we can do these inspections. And we are the best placed people to do them. But I do totally agree with you about clerks of works.
All right, Simon, thank you so much for your time today.
Thank you very much.
Thank
what
you.
What an honour.